Welcome my dear students. In this lecture series, I am going to solve you some of the interesting problem on physics from JEE Advanced perspective. So starting with that, so there is an object which is displaced from the point 1, that is the position vector r1 is given as 2i plus 3j, to position vector 2 r2, that is 4i plus 6j. Under the action of a force, this. Okay, so this force is a variable force. This force is a variable force. Now, because of this variable force, you are asked to calculate the work done by this force. Okay. So, you know that whenever the work done has to be calculated, so either we can calculate the work done by simply product of a vector dot s vector, or I can calculate as a vector dot dr vector. So, the second formulation, that the integration format has to be used whenever the force is variable. So, whenever the force is constant, so I should go for this expression. Now, for this question, the force is variable, so I have to integrate it. So, since the force is a 2D format force, so I should use the dr vector as our dxi plus dyj vector. Okay, so this is the formulation of the dr vector, that is for the 2D situation. Okay, now using that concept, now I can do the integration. So, total work done should be equal to integration of a vector dot dr. Right. So, F vector is how much? 3x square I plus 2yj. Now, we are making dot product with dr vector. So, dr vector is dxi plus dyj. Okay. And integration of this. So, ultimately, once you do the dot product, only the I component will be there. And j component will be there. So, ultimately, what you can write? Integration of 3x square dx plus integration of 2y dy. Okay. Now here I have to put the limit of x. So in order to calculate the limit of x, the position is initially x coordinate is 2. Now the final coordinate is 4. Okay. So initially the particle is at x, 2 location, and finally the particle goes to x equals to 4 location. So initial value is 2, then final value is 4. Similarly, initial coordinate for the 3, limit for 3, y should be 3, and similarly final limit for the y, that is the upper limit, will be 6. Now we have to integrate it. So it is 3x cubed by 3, limit 2 to 4, plus 3 times y square by 2, limit 3 to 6. So we are left with x cubed only 2 to 4, plus y square, limit 3 to 6. So finally 4 cube minus 2 cube plus 6 square minus 3 square. Okay, so that will be answer in your joule. So 4 cube is what? 4 cube is 64. 64 minus 8. Then 36 minus 9. Okay, so 64 minus 8 is 56. So 56 plus 36 minus 9 is 27. Okay, so that is 83 joule. So that will be your answer. So whenever we are doing the calculation for the variable force, so keep in mind that you have to go for the integration rule. So from that you can calculate the work done. So work done should be f dot dr, integration of that, and put the proper limit. So since the particle is moving from r1 to r2, get the limit of x as 2 to 4. So initial value of x is 2, final value of 4, and similarly initial value of y is 3, and finally it goes to 6, and putting the proper limit and do the calculation. So you will get the answer as 83 joule. Okay, thanks for watching my video. Please like and subscribe my channel.